Okay folks, so here we are. I am burn testing with Intel Burn Test. And it's basically Intel Burn Test is kind of like Prime 95, but it definitely works the CPU a little harder. It gets some better max temperatures out of it. As you can see, I've got some pretty good temperatures there in terms of like how much is being pushed. Now I did knock my CPU down to 4.4 gigahertz because one, there's too much of a voltage increase to go to 4.5, and my computer wasn't stable, having blue screens of death. So I figured, you know what, let's just drop it back down to 4.4. So right now, Linpack is obviously using, Intel Burn Test is using about 13.5 gigabytes of RAM. So that's put me at almost full physical memory usage. CPU is going at max load. So basically what I'm doing right now is this is going to be my airflow after I go in and kind of change some stuff. Because right now, we got this fan's on the front, it's pushing air in. This fan up here is actually pushing air out, same with this one, that one's pushing air out. This one currently is actually turned off, but actually it's gonna be going in. Essentially, this one right now is a Zigmatech fan that I can't mount either way, so therefore what it's doing is pulling air out of the case instead of in. So I don't have it turned on right now, because that would simply be too much air going out of the case, not enough air going in. So right now I've got this fan at 100%, these fans at 40%, and this one's just not even plugged in because it's just, there's no reason to. There's not enough airflow, because I'm trying to keep it at least close to middle grounds, maybe a little bit more air coming in than going out. But essentially the plan is I'm going to flip this fan here in a little bit after Intel Burn Test is done. It should be done in like 20 minutes or so. What I'm doing is essentially, because the CPU is right here and the fan on it is going that way towards there, and I figure with this one going out, this isn't getting like any cool air. So if it's coming down, the air is going to come down and it's going to suck the air right through. So I should get cooler temperatures on the CPU. Should. Because obviously up here is like hard drive bays and 5¼ inch bays, so can't put a fan there really. At least not easily, and there's like cables and stuff here. So if I have a fan going down here, that'll make a difference. Hopefully. I've heard that it kind of helps, and it would also probably optimize airflow a little bit better, because if we got stuff coming in from here, stuff coming in from here, and then this one's sucking in air to go directly onto the GPU, it should hopefully cool the GPU a little bit better too, because the GPU has a couple fans that I think bring air in, and then air goes out of the GPU back here. So right now, just finished up another one. Max temperatures have not gone higher than the first time, so that's cool. But my max temperatures before airflow optimized for the first time of doing it for the first test was 60 on one course, 71, 69, 67, and average across those was 66.7. And this is obviously 4.4 gigahertz at about 1.32 volts. And basically what we're hoping is these numbers will be docked by at least a few degrees, because every degree counts pretty much. So right now I'm just testing to try and get the absolute max temperatures I can get out of the CPU, and then I'll do the fan thing, and I'll probably test the GPU as well. GPU has typically been getting about 56 degrees Celsius lately with folding at home. So I'll probably just run that again after I do the whole thing. Maybe run Unigine Heaven and do that benchmarking, check the temperatures with that. But for folding at home before the airflow has been optimized, 56 degrees Celsius, which for only 45% fan, that's not bad. Because 45% is pretty much inaudible, so you can't really hear it. So essentially, with this one sucking air in, it'll cool the GPU, hopefully bring it down closer to 50 maybe. Because obviously with cool air coming directly into the GPU, and I'll use this duct that I have, that'll kind of aim the air more at the GPU. It'll hopefully do it'll hopefully make a good difference. So yeah, that's kind of what's going on right now. We're gonna hope that, this should definitely make some difference. And yeah, so I will let you guys go, and the next part of this video will have kind of more either like midway results or the end. So all right. Okay folks, so the test is over. Everything's done. One temperature went up, which was the first core. It went up on the very final test at 151, so about 5 minutes ago, thus making the CPU average come out to 67 degrees Celsius. So we'll basically use that to compare. We'll also look at core temperatures. So yeah, blah blah blah, your system was able to stay stable and everything. So as you can see, the temperatures mostly haven't gone up except for core 0. And for some reason it's going at 4.4 gigahertz, but who cares? So I did bring this down here. My dad is in Australia for a couple weeks, so this would otherwise be on the dining room table. It's a 17-inch, or maybe even 15. No, I'm pretty sure it's a 17-inch Dell Square monitor. Pretty nice monitor, but I'm probably gonna put it up like right there, and yeah, or maybe up there where the N64 is, but then I wouldn't have a spot to like praise the N64. Just need to move things a little bit, but yeah, so got the air duct here. This thing will help direct the airflow from the fan towards the GPU. It's could move on a Cooler Master's part. Oh yeah, I'm going to be putting in this old, check this out, Maxtor 80 gigabyte SATA 1.5 HDD to try and get some old files off my computer. So yeah, this will be fun. And yeah, drink Odwalla, it's healthy. So, alright folks, I will do a video kind of during, like after I've torn this thing apart a little bit, and you can see the inside as it is currently. So hopefully it won't have spider webs and crap in it like it did last time. So I thought I'd just show you guys a little bit of what Unigine Heaven is like for people who don't know what Unigine Heaven is like. Try and get that light glare out of there. This is an extremely GPU intensive application. It really is a test of your GPU's strength and weaknesses, and it can get some of the highest temperatures out of your graphics card. It's just about done, so we'll see the results here in a second. And I did not change any of the settings for this run. I just kind of opened and went, because that's kind of how you do it. So we've got a average frames per second was 56, score was 1411, minimum frames per second was 24.5, max was 127. Yeah, So now we'll see what the temperature is. I'll just save this really quick. Okay. And we'll quit. Alright. So it looks like the max temperature was... Oh, oops. Looks like it was about 63 degrees Celsius, with a chunk of this being in the 59 to 60 range. So we'll use 63 as the max temperature. Max memory usage was a little bit over half of the memory on this card. And yeah, so fan speed was locked at 45% the whole time, so that goes to show kind of how good the cooling really is. And like I said earlier, the 45% is pretty inaudible. This is a GTX 560 Ti from MSI TwinFrozer 2. I overclocked it from 880 to the core clock to 940. Shader clock is of course up from 1760 to 1880. Memory clock is up at 22 megahertz, which would of course be doubled to 4400 in the math of it all. So that's the graphics card results before airflow optimization. Okay folks, so yeah, so right now I'm just about to delve into the computer and rip it apart. It's still on, but it's just idle right now. So basically the results, I'm just going to throw these results at you again just so you know kind of like right now. So the CPU is at 4.4 gigahertz, 1.32 V-core, and Intel Burn Test pushed it to 67 degrees Celsius as the average temperature across the cores for the average like high temperature. The highest temperatures it reached for all 4 cores throughout all 5 tests, which ranged about 35 minutes or so. That was 61 degrees Celsius, 71 degrees Celsius, 69 degrees Celsius, and 67 degrees Celsius. And then we have the graphics card. I'm not going to bother with folding at home temperatures because I don't watch those as much with the CPU, because folding at home doesn't seem to really push my CPU too much. IBT and Prime 95 are much worse. So basically, we know that the folding at home is going to be lower than Intel Burn Test, so it doesn't really matter. But folding at home, because like with the, okay, so the graphics card is clocked at 940, 1880, and the fan speed is locked at 45%. So no matter what temperature the graphics card reaches, the fan is going to stay at 45. Obviously, if it gets too hot, it'll just shut down, but that's not going to happen. Folding at home has seen the graphics card be about 56 degrees max lately with a 45% fan. Heaven, obviously, as we saw with just open and go, it put the GPU at about 63 degrees Celsius. So these temperatures will be the ones that we'll be comparing to the temperatures that we get after the after I kind of optimize my airflow and get one fan turned back on, another fan flipped, and a duct put into the computer. So looks like this will probably be 2 videos, probably like 15-minute long videos or so. But you know, this is a whole process. I've been sitting here for over an hour since I did the Intel Burn Test now. Well, almost an hour. It's kind of shocking, but whatever. So yeah, so I think this is the end of part 1. Maybe there'll be 3 parts, because I'm sure I'll do some video footage for you guys for the inside of the computer, and yeah. And I'll probably have pictures in the video too. Alright, time to have fun.